Hey guys, in this video I'll show you a very interesting frame I managed to capture while making a video about the explosive decomposition of ozone into oxygen. So I got my ozone for today's experiment the same way I got it for all the previous videos with it, that is using this ozone generator.
This device is able to generate about 1 gram of ozone per hour. To operate this device, it needs to be connected to a permanent oxygen flow, delivered via oxygen cylinder. However, simple oxygen from a balloon won't be enough to get high concentrated ozone. Before oxygen is delivered in the device, it must be passed through a special tube with a desiccant. It represents an airproof plastic container with a pipe for gas inlet, a desiccant, which is silica gel, and an outlet pipe. So this is where we supply oxygen from the balloon. Passing through a desiccant, it becomes extra dry and then is delivered in the ozone generator, where it passes through the corona discharge in the special quartz tube, which makes some of the oxygen transform into that very ozone I'll be using in this video. Ozone is easily detected by smell, but YouTube doesn't carry over smells. So let's use chemical reactions to make sure we do have ozone forming. The reaction of ozone with potassium iodide solution and starch is the one that serves as a qualitative reaction to ozone. This reaction results in elemental iodine forming, and we can see the solution that is passed through ozone turn dark orange. When ozone reacts with solid potassium iodide, ozone creates elemental iodine and a thin layer of potassium iodate on the surface of potassium iodide. There is also one more or less known qualitative reaction to ozone, which is the reaction with the solution of divalent manganese ions. It results in the formation of brown manganese dioxide flakes. If we freeze the gas that emits from the ozone generator in liquid nitrogen, we'll get a bright blue liquid, which is ozonated oxygen. The richer the blue color of the solution is, the bigger the amount of ozone dissolved in liquid oxygen. The high content of ozone makes this liquid unstable, and we can see it kick abruptly out of the tube on a temperature jump because of the explosive ozone decomposition. It wouldn't happen with regular liquid oxygen. If we pour this liquid into the potassium iodide solution, we'll see the same reaction that occurred with gaseous ozone. If we add ozonated oxygen to silver nitrate, we'll get a very interesting compound called tetrasilver tetroxide. If we cool down extra dry ozonated oxygen neatly, so that no air gets into it and oxygen doesn't condensate, we'll be able to get a few drops of practically pure ozone that has purple color. Take a look at these guys. This is liquid ozone drops. Liquid ozone has an exceptional ability to decompose spontaneously. It took me a lot of time to capture a few drops of liquid ozone for this video. So, to demonstrate an explosive self-decomposition of liquid ozone, I will hit on the tip of the ozone-resistant silicon tube where liquid ozone drops gather. Filming at 120 fps, I managed to capture a peculiar frame. The moment the explosion occurred and ozone changed into oxygen, the whole tube got filled with bright light. The change between allotropic modifications followed by the glow is an extremely rare phenomenon in chemistry. Also, antimony might have this ability, but I'm not quite sure. Anyway, thanks for watching, I hope you enjoyed this video, and huge thanks to my patrons. I hope that with your help, this year will be the one when I'll make videos with even more slow motion, like those that Explosion and Fire does with his high-speed camera.